This is a sun-like star. It's in the constellation Cygnus. It's approximately 2,000 light years from Earth, so the light that Kepler is seeing from this star left the star around the time Caesar was making his conquests. Now, if we can have the video, this is a Kepler view of the system to begin. We see this target dimming like clockwork, but like a very special clock, one with 6 hands moving at 6 different rates. And we interpret this as 6 planets orbiting very near the same plane. Now looking at it face on, and these are very close in, especially the inner 5, very close to one another, the most compact system of planets ever discovered by any technique anywhere.
There's no doubt that the search for planets is motivated by a search for life. Humans are interested in whether or not life evolves on other planets. We'd especially like to find communicating technological life. And we look around our own solar system and we see that of all the planets, there's only one that's inhabited. And so naturally we think that finding another Earth-like planet is, identifying a site that's at least friendly here for the evolution of life. So the primary goal of Kepler mission was to statistically assess the occurrence of these small terrestrial worlds. And I remember in March of 2009, when I was here, right after the Kepler mission launched, and I remember commenting that the planets would begin to roll out of the Kepler mission like an assembly line, and that in the first year we could expect to see Jovian-mass planets or Jovian-sized planets, and after 2 or 3 years we'd see the Neptunes begin to roll out, and then finally the Earths. So I'm amazed to sit here today and see that Kepler is actually reaching the milestone discoveries faster, certainly, than I anticipated.
Well, how much does this bring us closer to discovering whether there's alien life? And second, how do you now find out if the 5 planets in the habitable zone do have life?
Patience. That's how it's done. And lots of money. That's reality. This mission is designed to do something and do it as well as can be for this first step. It finds the frequency of these objects, these planets, and their distribution. But you must do the other steps. You must, in some sense, build the cathedral. The first generation is going to build the foundation. The next generation is going to build the walls. Third generation is going to put the ceiling on. The fourth generation is going to enjoy it. And so we are, in some sense, the first generation. We're finding them. The second generation is going to build instruments of far more complexity than what we have to go and find these nearby ones. And even greater demands are going to be made to find the atmospheres on these planets. And then, of course, having done that, our grandchildren will have to decide what's the next step. Do they want to go there? Send a robotic system there? So this is only one step. It's an important step, but there are other steps that must follow.